नमस्ते दोस्तों। लास्ट लेक्चर में हम बेसिक्स ऑफ लैप्लास ट्रांसफॉर्म देखे हैं और स्टेबिलिटी एनालिसिस देखे हैं। आज हम देखने वाले हैं कि वंस अगेन व्हाट इज लैप्लास ट्रांसफॉर्म, लैप्लास ट्रांसफॉर्म ऑफ बेसिक सिग्नल्स और इनवर्स लैप्लास ट्रांसफॉर्म देखने वाले हैं। तो हमने देखा है कि लैप्लास ट्रांसफॉर्म क्या है। लैप्लास ट्रांसफॉर्म इज नथिंग बट द कन्वर्जन ऑफ टाइम डोमेन सिग्नल to the complex frequency plane, and thus Laplace transform is given by Laplace transform of x of t is equal to x of s. The signal in the time domain is represented by x of t, signal in the s domain is represented by x of s, and this x of s is equal to minus infinity to infinity x of t e raised to minus st into dt. The basis function for the Laplace transform is e raised to minus st. We are converting the signal x of t to x of s, that is into the s domain. This is also represented as x of t is a Laplace pair of the x of s. इसका मतलब है Laplace transform of x of t is x of s or inverse Laplace transform of x of s is equal to x of t. So already we have seen, and s is equal to sigma plus j omega, which is a complex frequency plane, and sigma is equal to real part of the s and the omega is equal to imaginary part of s. Mainly this Laplace transform is used for analysis of the system, and analysis of the system can be done in the s domain, and this s domain or the s plane is in a graph with respect to the real part of the s, that is a sigma, and imaginary part of the s, that is the omega j omega. And by locating poles and the zeros into the s plane, we can able to analyze the system, whether the system is a stable, unstable, whether it is a causal or whether it is a non-causal. Basically it is used for analysis of the system. Now we will start with the basic signals, and these basic signals are used to find out Laplace transform of any complex signal. So therefore the most important basic signal in the signal processing or the signal system is e raised to minus at u of t, which is called as the exponential signal. And already we have seen so how to sketch the signal in the time domain. So this is the time and the signal is x of t, and if you look, अगर आपने देखा है u of t मतलब signal is present from 0 to infinity to the positive side of this x of t, and e raised to minus at is a decaying signal. So this is a decaying signal. This is the signal in the time domain, and when you put t is equal to 0, e raised to 0 is 1. For the time t is equal to 0, the value of the signal is 1. This is the signal in the time domain. So same signal we want to represent into the s domain. So उसके लिए first step है, you have to write the formula. We have seen the formula for this is x of s is equal to minus infinity to infinity, so x of t into e raised to minus st into dt. So here this is a x of t minus infinity to infinity e raised to minus at u of t e raised to minus st u of t, and I told you the u of t is nothing but value of the signal is equal to 1 for time t is equal to 0 to infinity. So the limit will become 0 to infinity, value of u of t will become 1, so it is equal to e raised to minus at into e raised to minus st into dt. We know e raised to a into e raised to b is equal to e raised to a plus b. So this t is a common, e raised to minus is common, s plus a and t will be there, and we will find the integration of this. The integration of this is equal to exponential signal. So the e raised to minus s plus a into t divided by the derivative of this part, so that is equal to minus s plus a. So overall the integration of this is equal to minus 1 divided by s plus a into e raised to minus s plus a into t, limit will be from 0 to infinity. So you put the upper limit minus lower limit, so minus 1 upon s plus a, we will take it outside, and upper limit I will put value of t is equal to infinity, and lower limit I will put the value of t is equal to 0, that e raised to 0 is equal to 1 and t is equal to infinity, so minus infinity, so e raised to minus infinity is 0. So total it will become minus, minus and minus is equal to plus. So this is equal to 1 upon s plus a. So this is the Laplace transform of the signal e raised to minus at u of t. And सबसे important चीज है Laplace transform में the region of convergence. पहले ही बताया हूँ मैं, region of convergence is nothing but the value of sigma for which the Laplace transform exists. अगर आप इस इंटीग्रेशन में अगर आप देखेंगे, so e raised to minus s plus a into t. So to become this function, the convergent, the value of this s plus a, it should be greater than 0. If it is greater than 0, इसका मतलब है minus and it is a decaying function, the Laplace transform will become convergent. अगर आपको find out करना है region of convergence, you find out from this the part. So that is the real part of s plus a, because the ROC is nothing but the real part of the s. So therefore real part of s plus a, it should be greater than 0. Then only it will become the decaying function. So if it is greater than 0, so real part of s is greater than minus a. So this is the region of convergence, and region of convergence is very important. The next thing is you find out the poles. If you want to plot the ROC, आपको पता होना चाहिए कि where is the pole located. So pole is nothing but the denominator part. The roots of the denominator is called as the poles. So that is s plus a is equal to 0. So s is equal to minus a. So the pole is located at s is equal to minus a. So therefore this s is equal to minus a, just you plot the s plane, real part of the s, imaginary part of the s, and minus a will be to this part, and this is represented by the cross, and ROC is the real part of the s is greater than minus a. So ROC is nothing but the strip of parallel line parallel to the j omega axis. So therefore, so this is your the ROC. So it indicates, if you look at the signal in the time domain, so this signal is a right-handed signal. This is called as a right-sided signal. If the signal is right-sided signal, the ROC is also the right-sided. So इसका मतलब है this signal is actually the causal. So if the signal is to be causal, so that you can identify from the S domain that the ROC should present to the right-hand side of the pole. Now ROC is present to the right-hand side of the pole. So therefore, so the ROC is strip of this parallel line. So ROC is represented like this. And overall, the Laplace transform of x1 of t is equal to e raised to minus at u of t is 1 upon s plus a. And its ROC is real part of s is greater than minus a. And from this s plane also you can able to identify whether the signal is causal or not. So if the ROC is the right-handed signal, the signal is a causal signal. Okay, this is a causal signal, and we have seen in the stability analysis, if the s plane, that is ROC in the s plane, ROC contains j omega axis, the system is stable. So here the system is also stable because this is j omega axis that is present in the ROC. So therefore it is a causal and the system is stable. Both you can find out. So therefore Laplace transform of e raised to minus at u of t is 1 upon s plus a, and its ROC is the real part of s is greater than minus a. So accordingly we can find out Laplace transform of any signal. So this is Laplace transform of exponential signal. अभी हम देखेंगे Laplace transform of left sided signal. x2 of t is equal to minus e raised to minus at u of minus t. अगर u of minus t मतलब होता है the signal is present from minus infinity to 0, उसको हम left sided signal बोलते हैं. So let us see the signal in the time domain. So this is t and this is x of t. So this side is called as the right sided signal, this side is called as the left sided signal. अगर e raised to minus at मतलब it is decaying exponential signal which is present from minus infinity to 0. So this part is a minus infinity, यहाँ पे 0 है, the signal is present from minus infinity to 0, e raised to minus at मतलब it is a decaying signal. For the time t is equal to 0, the value of the signal is 1. Decaying मतलब here the signal is a decaying from minus infinity to 0, so this signal will become like this. So this is e raised to minus at u of minus t. और यहाँ पे माइनस है, माइनस मतलब the amplitude has become the negative. So same signal you can draw. So actually this x of t can be represented. Minus मतलब ये signal ऐसा दिखता है. So this is, if you see, so why it is called as the left-sided signal, because it is present at the left side of the y-axis. So it is a left-sided signal. Actually this is only e raised to minus at u of minus t. अगर minus e raised to minus at एंड u ऑफ माइनस टी है तो सिग्नल इस तरह दिखेगा. अभी आई वांट टू फाइंड आउट द लैप्लास ट्रांसफॉर्म ऑफ दिस सिग्नल. अभी सेम as I told you, you write the formula for Laplace transform. So this is equal to minus infinity to infinity x of t into e raised to minus st into dt. So x of t, just you substitute the values of x of t is minus e raised to minus at u of minus t and e raised to minus st into dt. Now u of minus t is nothing but the limit of this u of minus t will be minus infinity to 0. Just I will substitute and I will remove this u of minus t. So this is equal to minus as it is, e raised to minus I will take common, e raised to minus s plus a t into dt. और इसका हमें we want to find out the integration of the exponential signal e raised to minus s plus a into t is nothing but e raised to minus s plus a into t divided by derivative of this minus s plus a into t, derivative of minus s plus a into t is equal to the minus s plus a, because differentiation of t with respect to t is a 1, so it is s plus 1 and minus will be there, so this minus and this minus will become plus, so it is 1 upon s plus a, and limits will be from the upper limit is 0, lower limit is minus infinity. So 1 upon s plus a is, I will take it common, upper limit 0, so e raised to 0 is 1, minus lower limit is minus infinity, so this minus and minus infinity will become s plus a into infinity. So to make this function convergent, so this function should be negative, that is s plus a should be less than 0. When the s plus a is less than 0, so then it will become minus infinity and e raised to minus infinity is 0. So if you take s plus a is greater than 0, so this function will become infinite, so it will not become convergent. So to find out the region of convergence, so s plus a should be less than 0. When s plus a is less than 0, then only this part will become 0. So ROC will be less than 0. So real part of s is less than the minus a, and this function will become 0. So total of the Laplace transform of this function is equal to 1 upon s plus a. So the Laplace is 1 upon s plus a, and the ROC is real part of s is less than minus a. So minus a, I told you to find out the pole in the ROC. This is a s plane, real part of s, imaginary part of the s, and pole is located at s is equal to minus a. So this is the minus a, and the ROC is real part of s is less than minus a. So this part is a less than minus a, and if you see the signal is left sided signal, the ROC is also left sided. If ROC is left side to the pole, that means the signal is non-causal signal. So accordingly you can find out, and if you observe the Laplace transform of the previous signal, which is very important observation. So Laplace transform of e raised to minus at u of t. So Laplace transform of this is equal to 1 upon s plus a. However, the ROC is sigma is greater than minus a, and Laplace transform of minus e raised to minus at and u of this minus t. So this is right sided signal, this is left sided signal. The Laplace transform of both the signals are s plus a. So only from the Laplace transform you cannot distinguish whether the signal is right sided or the signal is left sided signal. So minus e raised to minus at u of minus t, इसका भी Laplace transform same है, इसका भी Laplace transform same है. So if the Laplace transform same है, you cannot distinguish. So main important factor is ROC. यहाँ पे ROC sigma is greater than minus a, यहाँ पे ROC sigma is less than minus a. So this is the main important difference in the Laplace transform of both the signal is the ROC. If ROC is greater than minus a, it is right sided. ROC is less than minus a, it is left sided signal, and ROC of both the signals are same. And this Laplace transform and ROC we are going to use in the inverse Laplace transform also, and we are going to find out Laplace transform of any complex signal from the exponential signal. तो आप लोगों को ये दो Laplace transform आपको याद रखना है. इसी Laplace transform से we will find out Laplace transform of any complex signal.